Good evening, folks. It's launch day today. My name is Magnus. I'm a rocket chaser for TLP, and I'll be your host for today's live broadcast. Today is the launch of Starlink 6-87, and it will be carrying 29 Starlink satellites to the 43-degree inclination, heading in a southeast trajectory. Weather today seems to be a tad bit of a holdup with couple couple cold fronts coming in. As you can see in your right side of the screen, um, weather is fine at the moment at the launch site. Winds seem to be a little bit of an issue. No precipitation at this point in time. But apart from that, looks like we should be able to launch, but we won't know that until 11 minutes and 30 seconds from now. On your screen is the general trajectory, which is heading to the southeast. The booster flying today will be B1096. B1096 is flying for its third time today, and it is 48 days since its last flight. B1096 previously flew Kuiper 1 and IMAP and others. This booster, after following separation, will be performing a landing just east of the Bahamas. As always, feel free to drop some questions in the chat while we wait. We are just around 10 minutes from launch at this time. Since weather will be the holdup today, we're going to throw up both of the weather radars. Going to throw up both the weather radars on the screen for so that you can visually see what's going on. These are pretty much live images coming in from the past hour. As you can see, we have some precipitation um, going through the flight trajectory there down in the southeast. It's coming from the west end into the east. We definitely have some winds and some clouds and a little bit of rain, which could impact the recovery. From what it appears like, yeah, that is going to be the main constraint is going to be that recovery zone weather. But apart from that, we are still, from our understanding, still looks like it's going to be launched today. Um, but again, there's no way of knowing that until we actually lift off the pad. This is the first launch that is affected by the new curfew initiated by the FAA, which prohibits launches from any time after 6 a.m. in the morning and between 6 and 10 p.m. at night in that local time zone. Local time in Florida right now is 10:12 p.m. So we're just around 12 minutes after that curfew. So this launch had to be placed then. First launch that is affected by that said curfew. Despite that curfew, doesn't look like there's going to be much of a on hold up on the launch schedule. We're looking at Escapade on Wednesday, which was going to get an exception to that FAA curfew. Should have VS. We might have ULA launching VSAT. A couple Starlinks launching in the evening, and we'll end the week up. End the week with Sentinel 6B launching from Vandenberg on Sunday. I'm going to go ahead and answer a question that has was just posed in chat. So, Judith White is asking, has a booster ever landed and then fallen off the recovery ship? That is a yes, and it has happened a couple times. Notable is B10 1058, which was the NASA Warren booster that fell off in we're getting close to 2 years now in December. Um, so typically that happens if there's an issue with some rough seas and the landing legs aren't able to support the weight. But yes, that has happened. As always, feel free to drop some guesses for the apogee of the booster. I personally think it's going to be at, if we go today, I think it's going to be 113 kilometers in altitude. Um, but we'll see. There's no way to knowing. Every time you're launching, there's always a little bit of those small indifferences in you're still going to be within that predefined trajectory, which is go on the range, but you're always going to be a little bit off. First stage isn't super precise when it's dropping that second stage. It's precise, but we're always going to be off by a couple meters a second. So because of the strength of those engines, that's why usually when you're launching a rocket, you have some fine tuning done by that second stage, and that's the one that's going to be putting the payload into orbit. Second stage engines usually have a lower thrust to weight ratio. Many of the times they're less than one, while first stage is one, especially when you're getting up there, have a thrust to weight ratio in the high twos, sometimes close to threes, making it quite difficult to get some precise, making it super precise. Even when things are operated by computers, a couple milliseconds is going to add some meters a second to the velocity, which is going to cause some diffrations in the apogee, which is exactly why we have those apogee guesses. So keep throwing in those guesses, and we'll lock those in during launch. We are just around 5 minutes from launch at this given point in time. That means that the booster has performed its engine chill. The we'll have completion of stage one and stage two LOX load in about 2 minutes from now, and we'll have the strong back retracting just about now. We'll hear that call out over the comms very soon.
Stromback retract has started.
And there you have it. Strongback is retracting, so that means we are still going ahead with launch. Uh, that takes a couple seconds. That strongback is going to retract a couple of degrees, um, and it will fully retract at liftoff. Up next, just about 20 seconds from now, we should hear the call out that stage one LOX load is complete, which should happen just about 15 seconds from now. And I can see those clamps on the second stage are open and the strong back is starting to retract. You should be able to see that on your screen at this given point in time.
Stage 1, LOX load complete.
And there's that call out. Stage one LOX load is complete. Up next, we'll have stage two LOX load, which will be complete in just around 30 seconds from now. And that stage 2 LOX load should end at just around now, awaiting that call out over the nets.
Stage 2, LOX load complete.
There's that call out. We are just around 1 minute from the go no go poll where the LD will confirm if weather is go and will be go for launch. Um, although 40 seconds from now, Falcon 9 will enter startup and it will purge those lines. You'll see quite a bit of venting as the liquid oxygen remaining in the fuel lines will be vented so that there isn't any
Gas
excess
launch
propellant that
closeouts.
is. And there's that call out. You're going to start seeing that venting happen very soon. Just around 20 seconds from now, Falcon 9 will enter startup where the onboard computers will take control of the vehicle.
Falcon 9 is in startup.
With that, Falcon 9's onboard controller computers have taken control of the countdown, and it is on internal power.
Launch director, go for launch.
And with that, we are go for launch despite the weather. Just around 30 seconds from now from liftoff. With Falcon engines will be igniting just a couple seconds before liftoff.
T-minus 30 seconds.
If we're lucky, we'll be able to see a little bit of that green flash caused by the T-tab as they enter the main combustion engine, the combustion chamber, and ignite the fuel. Just around 15 seconds from launch.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power. And liftoff. Go SpaceX, go Starlink.
And 1D chamber pressure is nominal.
Vehicles pitching downrange.
And liftoff of Starlink Group 687. Liftoff time was at 10:21:30 seconds p.m. Eastern Standard Time. Falcon is now carrying 29 Starlink satellites to a low Earth orbit. Up next, the vehicle will pass through maximum aerodynamic pressure, which is when the
Power
amount of stress
telemetry
is the
nominal.
highest, which is the highest on the vehicle. You should hear the call out for supersonic just around now.
Vehicle is supersonic.
And with that, the vehicle has broken the sound barrier. Max-Q just about 10 seconds from now.
Max-Q.
And with that, Falcon 9 has passed through the point of maximum stress on the vehicle. And you can see those, when it passes through that point, you can see a little bit of that contrail seen from that white exhaust there. Following Max-Q, the next event on the event list is going to be MECO. There's that call out for the second stage Merlin engine chilling with a little bit of liquid oxygen prior to its ignition, just around 1 minute from now. Up next, MECO will happen at 2 minutes and 25 seconds, followed by stage separation only a couple of seconds after that, and the second engine startup a couple seconds after that. So a lot of events in quick succession. The engines will shut down in a staggering positioning, so they shut down in pairs, with the center engine being the one that's on the longest, which you'll be able to see in that graphic in the lower right hand of your screen.
Main engine cutoff.
Stage separation confirmed.
And there is staging.
MVAC startup.
Great callouts there. That means second engine has ignited and it is on its way to space. A couple seconds from now, the fairings will separate, which are encapsulating the Starlink satellites. Look for those lights on the individual Starlink satellites, which will ignite.
Bearing separation confirmed.
And you can see those lights being eliminated. One is out, and there it is. At that time, it is second stage is going to be performing its burn, which is going to last just about 5 more minutes before that will shut down. At this point in time, the booster is reorienting itself using its cold gas thrusters, um, getting those getting the engine section facing downwards so that it can perform its entry burn just around 2 minutes from now. We should be reaching apogee in the next minute or so. As you can see, the speed is slowing down, um, and so that means our vertical velocity is getting close to that 0 point, and our horizontal velocity continues to be pretty quick. And there you have it. We are starting to descend again. That altitude did end up being 113 kilometers. At this point in time, the vehicle is gaining vertical speed as it starts to fall down. It's being pulled down by gravity, although it still has some of that horizontal speed. So um, it is going to land downrange just around 300 miles off the coast of the Bahamas. Not in the Bahamas. SpaceX is no longer recovering boosters in the Bahamas, but still pretty close by. In the next 30 seconds, we'll see that the velocity increase pretty rapidly. At this point in time, the vehicle is traveling about 2 kilometers per second, taking into account that horizontal and vertical velocity. And stage one entry burn is just around 40 seconds from now. Now, unlike Super Heavy, Falcon 9 is a little bit of a smaller vehicle and is built with the entry burn in mind. That means it uses the entry burn as its heat shield to protect it so it doesn't tear apart when it hits that lower part of the atmosphere. When that basically on the way down, booster is going to experience Max-Q again, and it wants to slow down and have a little bit of a protective shield, and it does that using the engines instead of a traditional heat shield, and that should be starting just around 10 seconds from now.
Stage 1 FTS has safed.
Stage 1 entry burn startup.
And with that, you just heard that the entry burn is starting up. 3 Merlin engines are going to start up there and bleed off a little bit of that velocity as we pass through that point of maximum aerodynamic pressure on descent so the vehicle doesn't break apart. You also heard that the FTS is safe. That means we are on a nominal trajectory and those FTS charges will no longer be needed.
Stage
should be
1
hearing
entry burn
FTS.
shutdown.
There's that shutdown for entry burn. We should be hearing also in just about 30 to 1 minute, 30 seconds to 1 minute from we will hear, and we just heard that there was that stage 2 FTS is saved, meaning that we are on a nominal trajectory there. Range has cleared second stage, so no need for those FTS charges anymore. Now, in the event that something does go wrong on the first stage during its landing portion, the first stage is purposely aiming on the side of the drone ship. So if that landing burn doesn't start or a grid fin goes out, it's going to hit the water and not the drone ship itself. Obviously, not hoping for that. We're hoping for a smooth landing just around 1 minute from now.
Stage 1 transonic.
just around 20 seconds from that landing burn. Look, that little dot there seen in your screen appears to be the drone ship, the lights on the drone ship. So that is getting quite close. We'll be performing that entry burn, that landing burn in just around 10 seconds from now. As you can see, the booster isn't aiming
Stage
for
1
it
landing
just
burn.
yet.
Stage 2 terminal.
And there's that landing burn start. It pitches over a little bit so that it changes the trajectory so it lands on the ship, which hopefully should happen just a couple seconds from now.
Stage 1 landing leg deploy.
Great views of just read the instructions. And we can visually confirm stage 1 landing is confirmed. And there you have it. B-1096 has landed for the third time on the drone ship. Just read the instructions. Up next, we should have SECO just around now.
I'm back shutdown.
And there's that SECO. Falcon 9 will coast now for the next 30 minutes before it performs a quick 1 second burn. And there's that call out for nominal orbital insertion. As you can see, it's venting a little bit of liquid oxygen, but the vehicle will now coast for the next 40 minutes before it performs that burn and then deploys those satellites, which will use their electric propulsion thrusters to raise that orbit. Unfortunately, SpaceX doesn't show any onboard deployment views anymore. Which means that we are going to wrap up our broadcast at this time. I'd love to thank everyone for watching today, especially give a big thank you to all the veterans. Tomorrow is Veterans Day. If you do meet a veteran, shake their hand, say thank you to your for their service. If there's any veterans watching at this time, thank you so much from the entire TLP team. Thank you for your service. We appreciate y'all. Appreciate all the viewers today, and from everyone at TLP, thank you for watching us. We hope to see you again very soon because space is better together. And good night.